Alright, well today we're going to be talking about representing functions of as power series. Okay. Okay. So let's take our first example. Okay. And this is going to ask us to find the power series representation of f of x equals 2x over 1 plus 3x. Okay. And here's going to be a very useful fact. Is going to be that 1 over 1 minus x. That's going to be 1 plus x squared plus x cubed, and so on. Okay. And, we can represent this as the sum from n equals 0 to infinity of x to the n. Okay. Using composition, I'm going to call this h of x. Okay. So I'm going to do composition here. And I'm going to say, hey, what happens if I replace x by minus 3x? Well, then I'm going to have 1 over 1 minus a negative 3x via composition. This is the same as 1 over 1 plus 3x. Okay, well, instead of having x in the series, I'm going to replace x by a negative 3x. Okay. Okay, so that's just composition, and if I write this as a series, okay, I'm going to get minus 3x raised to the nth power. I can write that as the summation from n equals 0 to infinity of minus 3 to the n multiplied by x to the n. Or I can keep it in its original form. Either one is fine. Okay. Okay. So this comes very, very close. This h of minus 3x comes very, very close to f of x. In fact, f of x is going to be 2x times by 1 over 1 plus 3x. And hey, I can write this part as a series. So I can write it as 2x multiplied by 1 minus 3x plus 9x squared minus 27x cubed, and so on. I can also write that as 2x multiplied by this summation from n equals 0 to infinity of minus 3 to the n multiplied by x to the n. And I think that this will simplify to twice, or I'll put the 2 inside the summation. Okay, but it's okay either way. Twice the summation, or twice the summation from n equals 0 to infinity of 2 times minus 3 to the n multiplied by x to the n plus 1. And this is our power series representation. Okay. Now, one thing that I want to emphasize here but I won't go into detail because it's not the emphasis of today's lecture, is this. When can we represent f of x, which is going to be 2x over 1 plus 3x, as the series summation from n equals 0 to infinity of 2 times minus 3 raised to the nth power multiplied by x to the n plus 1. And my answer, well, I'm just going to reference how you're going to do it. You're going to use the tests for convergence or divergence. These tests include the ratio test, the root test, the alternating series tests, etc. Okay. This isn't the emphasis of today's lecture. The emphasis was finding this representation that's in the box here. Let me go over one more quick example for you. Okay. And it's going to be to find the power series representation of here, f of x is going to be this ln of 5 minus x. Okay. And, you know, one thing that I'm going to note, and I could have listed this in two ways, is that if I take this derivative, this will be 1 over 1 minus 5 minus x, okay, multiplied by the minus 1 power. Okay. And this minus 1 power I can distribute to the denominator if I want, or I can keep it as it is. I'll keep it as it is for now. This will be minus 1 over 5 minus x. If I put it in the denominator, this would be 1 over x minus 5, just swapping the role of the negative in the denominator. They're all the same. Okay. So, what's the key point? Why did I differentiate this? ln of 5 minus x, that's going to be this integral of minus 1 over 5 minus x. Okay. That's why I did that. Okay. And my goal is to find a power series representation for what's inside the integral. Okay. So I'm going to let h of x is going to be 1 over 1 minus x. This comes very close to what we have here. And as a series, I can represent this as 1 plus x squared plus x cubed, and so on. This will be the summation from n equals 0 to infinity of x to the n. Okay. Now, we know this formula for h of x via the geometric series because it is a geometric series. What I'm going to do now is I'm going to compute h of x over 5. This is going to be 1 over 1 minus x over 5. Okay. And that's going to be 1 plus x over 5 plus x over 5 squared, and so on. This can be represented as the series where I just replace x by x over 5. That's composition. Well, why did I do that? I'm going to take this series representation, 1 over 1 minus x over 5, okay, and I'm going to multiply it by this quantity. Is going to be minus 1 over 5. Okay. And on the right hand side I'll have minus 1 over 5 times 1 plus x over 5 plus x over 5 squared, and so on. Okay. This continues down to be minus 1/5 times the summation from n equals 0 to infinity. And by the way, in that series, I needed to have that to the nth power. Okay, so I'll have x over 5 to the nth power, like that. Now if I perform this multiplication, then -1, I'm going to multiply numerator by numerator, but then I'm going to have to distribute the 5. So 5 times by minus x over 5 just becomes minus x. 5 times 1 gives me 5. So I think I have minus 1 over 5 minus x, and I have the series representation of this. Great. So now you're going to tell me that this ln of 5 minus x, this is equal to this integral of minus 1 over 5 minus x dx. But now I can take the integral of each term here. Integral of the summation from n equals 0 to infinity of minus 1 over 5 to the n plus 1 multiplied by x to the n dx. Now if I integrate this term, well, the x is the only term that gets integrated. So I'll have x to the n plus 1 divided by n plus 1. And then you're going to tell me, hey, there's a constant of integration. So sure. Okay. This is our representation, but we can do one better. Let's determine the value of c. And one thing that I'm going to do is I'm going to say, hey, I'm going to let x equal 0. Then this left-hand side becomes this ln of 5. The right-hand side is this summation from n equals 0 to infinity of minus 1 over 5 to the n plus 1 multiplied by 0 to the n plus 1 divided by n plus 1 plus a constant. So this says ln of 5, that is this constant of integration. And what I'm going to do now is I'm going to say, hey, I'm going to take out that constant of integration right there, and I'm going to put in ln of 5. This is the power series representation. Now, of course, we can ask this question: when can I represent ln of 5 minus x by the series on the right hand side? And again, because this isn't the point of today's lecture, I'm just going to say we can use the methods of convergence or divergence, i.e. the tests that we have previously used, to see when the series converges. And such tests include the ratio test, the root test, the alternating series tests, the integral test, the comparison tests. Okay. And we can use any of those tests, whichever one will answer the question, to determine when the series converges to the function. Okay, thank you very much.